Hello. So we suffered a power failure, and because of that failure, I had to stop. So let me continue from where I stopped. I stopped accidentally because there was a power failure. So we have been talking about the black holes, and black hole is a result of supernova, and depending on the mass of the dying star, if the dying star has a mass of the order of uh, 20 onwards, 20 solar masses, then there's a probability that this star may transform into a black hole. And if, uh, if, if the dying star has a mass from 10 to 14 solar masses, then there's a probability that this star after supernova will transform into a neutron star. So we have been talking about the space-time curvature, and in vicinity of the black hole, the space-time curvature is extremely large. It's that much large that it's impossible for a particle like photon to leave the space-time curvature. And there's a domain defined in the framework of the black hole's space-time curvature, what's called as event horizon. And, uh, and up to this event horizon, if a particle is moving towards the event horizon, it cannot cross this event horizon, even if the particle that's in discussion is a photon. And then the point is that then we have another framework here that comes from Stephen Hawking, who's trying to explain he's trying to explain the death of a black hole itself. I mean, is it possible? So what appears to be a mathematical reality for this black hole is that if a light particle cannot escape from the gravity of this black hole, then probably nothing is going to come out of this black hole. The black hole will stay as a black hole forever. But that's what is counteracted by Stephen Hawking by putting up the particles. If you have two particles in the event horizon, there's applying the ideas of quantum mechanics to describe that there is a finite probability that the black hole may lose energy, and they may die in a very, very long range of time, in a very long span of time. So uh, now talking about Milky Way, I mean, Milky Way it's observable to us. It's huge, and its length is of the order of 100,000 light years, and it has billions of stars in it. And what we see is that the center of the Milky Way is filled with black holes, and the black holes that are experimentally that are found using observational telescopes. There's a long range of black holes that are available at the center of Milky Way galaxy. There are black holes whose sizes are small. The black holes whose sizes are small, their creation is explicable, and we can understand that under what circumstances a star can transform into a black hole. But at the center of this Milky Way, in addition to that cluster of black holes that are roaming at the center of the Milky Way, there is a huge black hole, what's called as Sagittarius A, and this black hole is massive. I mean, it's so huge. We don't understand the origin of this black hole. There is no scientific explanation for why such a kind of giant black hole comes in existence. And there are some framing theories, but in reality, we don't understand the creation of that giant at the center of Milky Way galaxy. There happens to have some presumptions like. The presumptions like maybe they already happen to have some black holes in the space, and it's those black holes who come and interact, and they might have merged into each other and created that huge black hole that we can see at the center of Milky Way galaxy. Now, on the other hand, we have another class, what's called neutron stars, and these neutron stars, they have massive mass, and the cores of these neutron stars, they contain neutrons, and their crust, if you think about the surface of the neutron stars, they probably contain some heavy metals and electrons. The neutron stars, they their existence is based on that limit that I was talking about. That why they become a reality to the universe is a result of supernova again. So these neutron stars, we have highly spinning neutron stars. They create tremendous magnitude of magnetic field, and we can intercept those magnetic fields that are generated by these neutron stars. And what becomes more augmentive at this point of time, what becomes more philosophical at this point of time, that our predictions can go beyond neutron stars. Maybe we have bodies out there which have their cores made of quarks. I mean, you can have such a tremendous collapse of the matter that even the subnuclear particles like protons and neutrons, they can become mobile, and you can have a star, you can have a remnant of a star, I should say, made of quarks. And things can go beyond that, and we don't know exactly how things are happening accurately in the purview of evolution of the universe. So I think here I would like to stop, and next in the next talk, I will continue from here to go with more philosophical modulations that we have in the framework of physics for understanding the universe, for understanding the big, and for understanding the small. But I would like to intervene to a single point before I leave this stage, is that general theory of relativity is capable of explaining the things that are happening at macroscopic level, and quantum theory is able to explain the phenomenon that are happening at the microscopic level. But the genius of the universe is such that it seems to be working at these two extreme possibilities, but we fail to merge down the general theory of relativity into the quantum theory, where we can come up with a compact equation that can tell us about the both directions, the direction in which you are dealing with a massive object, and the direction in which you are dealing with microscopic particles like atoms, molecules, protons, neutrons, and so on and so forth. So people have worked a lot, and they try to mix up the two, but they have to deal with some with such kind of complications that it becomes impossible to have a merger of general theory of relativity and quantum theory. At the same time, the predictions that we have, the predictions with respect to our existence, in the solar system, with respect to our existence in terms of the Milky Way galaxy, this existence seems to be very minute. But with respect to the existence on the planet, the humans have attained that state where at least they can predict things by virtue of the evolution, by whatever you call, whatever the religion you have, it's by virtue of the God, by virtue of whatever is there, we are able to predict the things that are happening at large scales to a very good extent, and the things that are happening at the microscopic state. Even though the understanding that we have is meager, but when you compare the understanding that humans have, is something plausible, is something great. Certainly, there is some kind of support that's given by the universe, by the evolution of the universe, and that has led us to have some understanding of what's going out there. But at the same time, I will tell you, as much we have understood, more than that is there what we cannot understand.